Hello everyone, this is Dr. G. Anita Hebsiba, Department of Chemistry, Dr. S.N.S. Rajalakshmi College of Arts and Science, Coimbatore. This video is about a novel dyeing technique called electrochemical dyeing. So electrochemistry is all about reduction and oxidation, which takes place due to the loss and gain of electrons. So loss of electron is oxidation and gain of electron is reduction. So here we use electrochemical technique for dyeing. So the reduction process or its oxidation process which happens during a dyeing process is taking place with the help of electrodes, not chemicals. So here acid dyes. Electrochemical dyeing is a process that uses electrical energy to reduce organic dyes and dye fabrics. The dye is reduced by contact with an electrode surface, not chemical. The process can be direct or indirect, and the voltage must be controlled to prevent over-reduction. The electrochemical reduction of dyes can be direct or indirect. Direct reduction is used for sulfur dyes, while indirect reduction is used for bad dyes and indigo dyes. Carbon felt, stainless steel, and nickel were some of the electrodes used in electrochemical dyeing. So we need a cathode and an anode for this electrochemical dyeing to take place. So some of the electrodes are listed here. Electrochemical dyeing can be more environmental friendly and economical than traditional dyeing methods. It can also be used to dye fabrics sustainably with a reduction medium which can be recycled. Electrochemical dyeing. In this, chemical reducing agents are replaced by electrons from electric current, and effluent contaminating substances can be dispensed with articulate. So there is no effluent which is coming out of a dyeing bath here. In conventional method, reducing part of chemicals cannot be regained, so recycling of the bath is not possible. So due to residual chemicals and unused dye in disposal liquor, problems will generate due to non-eco-friendliness. Here, electrochemical dyeing introduces a big boon for textile dyeing. This process was developed by BASF. The first attempt was made in this context by reducing the amount of sodium dithionate by the application of direct voltage, that is sulfur dyes. This results powerful reducing agent species due to the decomposition of hydrosulfide and production of free radical ion SO2-. In this case, also recycling is not possible. Then it's one step ahead in electrochemical dyeing. Direct electrochemical dyeing. In this technique, the dyes have been reduced by direct contact of electrode and dye. But the partial reduction of dye should be carried out by conventional method. Then complete reduction is done by electrochemical process which facilitates improved stability of reduced dye. In order to start the process, an initial amount of leuco-dye has to be generated by a conventional reduction, and by adding the small amount of the reducing agent, then the reaction set in by electrochemical process. It is not needed anymore, and further process is self-sustaining. The system is successful in the case of sulfur dye. Initially, we reduce a dye in leucoform to leucoform by conventional method, and then it is sustainable. In the coloration of cellulosic materials, the position of indigo is unique, especially for the production of denim. The use of indigo dye involves a reduction step to attain a water-soluble form of the dye molecule that has high substantivity to the cellulosic fiber. In the dye house, usually the reduction step is carried out by adding sodium dithionate as reducing agent in the presence of sodium hydroxide as alkali. The former is very unstable, decomposing oxidatively and thermally to several byproducts. Some of these byproducts are sulfur compounds which pollute the sewage a lot. So when we go for this electrochemical dyeing, these problems can be rectified. Solving pollution problems arise from the use of sodium dithionate seems attainable by the technique of indirect electrolytic reduction. This is not to show the feasibility of the electrochemical reduction, but to characterize the dyeing behavior of indigo in order to reproduce the results of dithionate reduction with an environmental process which can be applied at industrial scale. Therefore, experimental dyeing was done in more simplified conditions. The redox potential of the solution was controlled along electrolysis. Electrochemical reactions were also controlled by potentiometry with imposed current. So we have devised an eco-friendly dyeing and with a possibility of reusing the dye liquor, and hence it it's a very novel dyeing technique, but the disadvantage is this cannot be applied. This cannot be immediately applied for the in textile industry for mass scale. Okay, now it is in trial level. So in future, it will be uh, it will be the conventional practice of dyeing industry. Thank you.